Today we're going to solve logarithmic equations. And I would say out of all the things we've done recently, this one is going to be a little more challenging than some of the other equations that we've done. And it's not so much the logarithm part, but it's the solving equations part. You can do it, but it's going to be a little more challenging for you. All right, so there's two types of logarithmic equations. And on all the types of logarithmic equations, we want to isolate the logs first. So if there's something added or subtracted or multiplied to the logarithm, you want to get rid of it first and then decide what type there is. So one thing about a logarithmic equation is you're going to see the word log. So anytime you see log in the equation, it's logarithmic, and you're going to decide which type it is. All right, so one type is log equals a log. And it's probably the easier type. So when it's log equals log, you just drop off the logs and solve the equation. And then the other type is log equals a number. And when it's that type, you're going to do the loop and write it in exponential form and then solve the equation. All right. And then another thing we have to think about whenever we're solving logarithmic equations is extraneous solutions. So extraneous solutions occur when you get an answer that doesn't work when you plug it back in. So it's also called a false solution. So on logarithmic equations, we're going to make sure we check our solutions. And what happens is when you plug it back in, you get some kind of error. Like you get a negative in a place you can't have a negative, and it just doesn't work. All right, so let's look at example 1a. We're going to solve the equations and we're going to check for extraneous solutions. Now here's our logarithm. There's nothing outside of it added or subtracted to it, so it's already isolated. And this one is log equals a number. And anytime it's log equals a number, you're going to rewrite in exponential form. All right, so that's the loop. So what we would do is write that 4 to the second power is equal to 2x plus 6. So that's like the very first thing we learned about logarithms. All right, and then 4 squared is just 16. All right, and then we're just going to solve this for x. So there's just a couple of steps. We would subtract the 6. And then divide by 2. All right. And then x is probably going to be 5, but let's just make sure. All right, so to get log base, if you guys remember, it's alpha window 5. And then I'm just typing in over here where I wrote check. And it gives us 2, so it checks out. Okay, so that is one type. Right, when we look at B, the logarithms are already isolated, and this one is definitely log equals a log. And when we have log equals a log, you just drop off the logs. All right, so we end up with 4x minus 2 is equal to x plus 7. And this one's not too terrible to solve. We would just get our x's together. Right, and then a couple of steps, adding and dividing. Okay. Now, what is the base whenever you don't see one? 10. So you have two options on this one. I feel like I might have forgot to tell you this when we did it the first time. There is a log that is right beside number 7. That is log base 10. So on one like this one that we're checking, if you want to use that button, you can. All right. So if we just hit log right beside number 7, that's log base 10. If you like doing it the other way and just putting in a base of 10, it also works. So we get 1 on the left side. And we get 1 on the right side. So this answer checks out. All right. So C is where they start getting a little more difficult to solve. All right. So this one is log equals a log. So we're just going to drop off the logs. So x squared minus 4x equals 12. Okay, so this is a quadratic equation. And whenever we're solving quadratic equations in this lesson, we're going to get everything on one side and factor. Now, I know factoring is not most people's favorite thing to do. Some of you are definitely better at it than others, but in Algebra 2, it's just something that will not go away. It comes up again and again and again. So to get everything on one side, I know that if 12 is positive over here on the right side, is going to be negative on the left side. Or you can think of like you subtract it from each side, whatever way you need to think. Okay, then we have our two parentheses. I know to get x squared, it's going to be x and x. And then I also know if this is a minus, that my signs in the parentheses are going to be different. One will be a plus and one will be a minus. And then if you all wanted to use that yellow sheet, sometimes people keep it in their notebook, you can, but we want two numbers that multiply to give 12 that are basically going to subtract to give you 4. Any idea? 6 and 2. Very good. And then because I want negative 4, I want the bigger number to be the negative number. All right. So hopefully that's not as confusing as it was the first time you learned it. So that means that either x plus 2 is equal to 0 or x minus 6 is equal to 0. And so that gives us two answers, possibly two answers. Possibly only one of them will work. All right, so I'm going to put them into the original problem. All right, so this is another one that's log base 10 that we can just use the log button that's beside number 7 if you wanted to. All right, so when I plug in -2, I get that. I get an error. That's because I'd have to turn around. That should be minus, sorry. If you get an error and it's really an error, that means it's not a solution. That one was just because I messed up. All right, so I get that ugly decimal. And so I would type in the other side and see if I get the same ugly decimal. And I do. So -2 checks out. All right, and then I'll do the same thing for 6. I get that same ugly decimal that I got for log of 12. So 6 also is a solution. Okay. Which one? On the calculator? Oh, the whole problem? Oh, sure. Okay. Let's look at D. So D is the first one we've done that we're doing that we have to isolate the logarithm. So because I have this +2 added on the outside, the first thing I want to do is subtract that 2. All right, so be careful. We did a couple in a row that were the same. Log equals log. Then we dropped off the logs. This one is log equals a number. We are not dropping off the logs. We're going to write in exponential form. All right, and writing in exponential form is doing the loop. All right, and then 2 cubed, 2 times 2 times 2 is going to give you 8. All right, so we're back to another quadratic equation. How did I get 8? All right, so this is a quadratic equation. So we're going to do the same thing we just did. We're going to get everything on one side so we can factor it. So I'm going to move the 8 over. Right, and this is another situation where I know that that's a minus, so I need different signs. One plus and one minus. And this time I want the bigger one to be positive, so I can get a plus 2. All right, so what multiplies to give you 8 and subtracts to give you 2?
1, 2.
Yep, good job. And because we want the positive 2, we'll have make the bigger number positive. So x plus 4 equals 0, or x minus 2 equals 0. And again, we're going to get 2 answers, possibly. Okay, so I put negative 4 in for x. All right, and see if that gives us 5, and then do the same thing with 2. Very distracted today. All right, this one is base 2, so we do have to do log base. All right, and then outside the parentheses, we would want to do a plus 2. And we do get 5, so that works. All right, it looks like they both work. Okay, let's do one more. All right, so this one is going to be log equals a number. So we're going to write in exponential form. So what's the base going to be if you don't see it? What's the base on this one? 10. Someone's whispering it, I think. So no base means base 10. So 10 squared is equal to 50x over x minus 1. All right, 10 squared is 100. I say this a lot to my pre-calculus class and sometimes my calculus class, but if you're solving an equation and there's something on the denominator or in the bottom that you don't want, do you guys know what to do with it to make it not in the bottom anymore? Just multiply by it. So if there's something in the denominator and I don't want it down there, just multiply. So it would be 100 times that, x minus 1, would just equal 50x. All right, so then I would distribute that. Just a couple of steps. I'm going to get my x's together by subtracting 100x. And then divide by negative 50. And we would want to check it. I'm just going to tell you it works. All right, so what questions do you guys have on logarithmic equations? Two types. So you first decide log equals log or log equals a number, and then solve it the best you can. All right, so your assignment is on the back.